Welcome to the online lectures for information security. Now we've moved on to the last topic of our first unit. In today's class, we'll be discussing secure software development. Now, within the previous class, we have studied SDLC and how you're going to securely develop the software cycle. But when you're focusing on the software development life cycle, you get to know the different principles that you need to follow and what are the different problems that might arise when you're developing a secure software system. So within the software, within this entire unit, we've studied about many systems. We have studied the different data procedures, networks. So many of the issues discussed in this chapter, they become the root cause of the software elements within the system. So how you're going to develop the secure software development. Now, many people or many organizations recognize the need to include planning for security objective. That is security, it cannot be achieved like in an instance. You need to plan for security. Now, when you need to plan, you need to identify what are the different problems that can arise within the software. Then how you're going to remove all those problems. You need to make a plan for removing those problems. In the SDLC, they used to create systems and have put in place procedures, different procedures to create software that is more able to be deployed in a secure fashion. Now, within the secure software development lifecycle, we have studied SDLC and secure SDLC. Now, within that SDLC, we had different phases. The different phases were investigation, analysis, logical design, physical design, implementation, maintenance, and change. So those are your different procedures that you're going to develop so that they can be deployed within a secure fashion. Now, this entire approach of software development is called as software assurance, in short, SA. The next topic within secure software development is software assurance and the SA common body of knowledge. Now, this together will be called as SWA CBK. That is SW for software assurance and CBK is common body of knowledge. So this the US Department of Defense launched the software assurance initiative. So this were the first people that identified that you need to develop a software assurance body so that we can securely build a software. So was this working group was formed to examine two key questions. Now, what were the two key questions? Now, the questions were what are the engineering activities or aspects of activities? Like you need to know how you're going to engineering and those all different aspects within the software that you're going to design. So what are the engineering activities or the different aspects of activities that are relevant to achieving secure software? Now in here you're going to have different set of engineering activities. So within this engineering activities, the ones that are going to provide you with security, only those need to be embedded for designing a secure software. That is the first key question. The next one is what knowledge is needed to perform these activities or aspects. Now in here, few activities I told that these are used for security. Now within the security, now to implement security, you just cannot make use of that two different tasks and embed security. You need to have a proper knowledge of how to implement this within the software. You need to know how you have to implement this within the software. So these are the two things for this. The SWA CBK was established. Now there are few key points or few sections in which this WACBK focuses on. That is the natures of dangers, fundamental concepts and principles, ethics, laws, governance, secure software requirements, the design, software construction, verification, validation, evaluation, the different tools and methods, what is the process that you're going to follow, how this project is going to be managed, how you're going to secure the software, and then how this entire secure software is going to sustain. These are the different areas in which the SWA CBK focuses on. The next topic is software design principles. Now within the software design principles, a good software development should result in a finished product that meets all of the design specifications. Now within software engineering, we have studied that whenever a software is being developed, you're going to have the end user and you're going to have the developer. Now the developer, whichever software he develops, this software should have all the features that were stated by the end user. They need to be present within the software. Then it is called as your good software. Then information security considerations are critical component of these specifications. Now it is not necessary that you design the software that has got all the end user specification that were listed, but in here whatever information is being stored within the software or what is being given out within the software, that also need to be considered. That is, the information security considerations are critical component. This is the most important component whenever you're designing a software. A critical component of these specifications, though, has not always been true. Now within this, there are a few principles that are designed. Principles that need to be followed. The first one is the economy of mechanism. Now within this economy of mechanism, this is going to focus on keeping the design as simple as possible. Design should be simple. The next one is fail safe defaults. The second principle. Now in here, fail safe defaults means in here you need to give on access to the person that is going to have access to the software. They need to be authorized permissions that are given access to the user. This access should be given on permission rather than exclusion. Then the third one is complete mediation. Now within complete mediation, in here this focuses on every access to every object. It should be now this access that was given in here. Now who is accessing this specific object? This need to be checked by the authority. The access that is given to a specific object, this should be checked by authority, that whether an authorized user is accessing this or an authorized user is accessing this. Then the fourth one is open design. Now this open design means the design should not be kept secret. Design should not be kept secret, but in here the design, it need to be dependent upon like who is given access or password protection that you can give, but it should not be kept secret. What is being built, that you need to keep it open, but if you want to safeguard your files, you can give them password protection. Then the next one is separation of privileges. Now within the separation of privileges, you need to focus in here upon the protection mechanism that is kept in here. Like you're giving password protection to the file. Now if you're giving password protection, along with this you can uh, give another authentication method, like you need to have this face ID is there or something, so that extra privilege need to be added, like 2 keys are required to unlock. Then the next one is least privilege. Now least privileges means, now in here whenever you're designing a software, you're going to have the highest privileges and the lowest privileges. Like the highest privileges are going to be given to the developers. Now some least privileges might be given to a specific employee. So this least privileges is not going to give access to the entire software, but it is going to give you access to some part of the system. So least privileges should be given to people that are responsible to complete the job, or the people that are necessary to complete the job. Some specific privileges need to be given to specific employees. Then the next one is The least common mechanism. Within this least common mechanism, the different shared variables that you're using within the software, or this is called as your minimize mechanism. This minimize mechanism need to be common to more than one user. It needs to be common to more than one user. The different shared variables or the different mechanisms, this should be not given to only one user, but they need to given to more than one users. Then the last principle is psychological acceptability. Now, within the psychological acceptability, it is essential that the human interface that you're making, or the user interface, this needs to be designed by the ease of use. That is, it should not be complex. It should be as simple as possible. Now, this should be simple because in here, if people are given job to maintain the software, or some routine checks need to be done, so that can be done easily. Or the people that are going to use the software, they are not going to be highly skilled people. Minimum knowledge, they've got minimum knowledge to do the job. That is why the user interface that you're designing, it should be easy to do, easy to use. Now, whenever you're designing a software that is easy to use, now if suppose you're designing a software for experienced people also, it is going to help you do the job quickly. That is why you need to design the user interface based upon the ease of use of the software. The next one are the software development security problems. Now, within the software development problems, we are going to focus upon some 20 problem areas that are going to arise whenever you're designing the software. Now, those 20 problems, they are called as the deadly sins in the software security. Now, the different problem areas we are going to study. The first one is the buffer overrun. Now, during a buffer overrun, an attacker can make the target system execute instructions, or the attacker can take advantage of some unintended consequences. Like within the DOS and DDoS attack, we have discussed that on one system, if multiple requests are sent at a time, this is going to slow down the software. What you're doing is, this particular software is going to have some specific buffer that it can response to some specific amount of request at one particular time. So you're sending multiple requests at a time, so this entire buffer gets full, and this is going to slow down the speed of this server system. The server is going to slow down. Now, when the server is being slowed down, so this attacker in here he can take advantage that if you're slowing down the website of a particular online sales, so what you're doing is, people might not be able to purchase items, so you're minimizing the orders that are placed on a particular website. This can be done by some rival website also. That is called as your buffer overrun. Now, within this, you're sending data more than it can handle. Occurs when more data is sent to a program buffer that it is designed to handle. Now, for many online seminars or lectures, they might design a buffer for some specific user, for 240 users or 250 users. Now, you might see that within the specific website, whenever you're registering, it tells you that you've got only 240 reservations or only 300 reservations. Now, beyond that, this particular website, it cannot access. That is why they are going to limit the seats so that the server does not slow down. The next one is command injection. Command injection problem occurs when the user input is passed directly to compiler or the interpreter. That is when a user is giving an input, a key stroke or a mouse key. Now, that input is directly passed to the compiler. Now, this is called as the developer's failure. That is a software that was designed. The developer did not make sure that this command needs to be validated. All the commands that you're sending, or all the commands that the user is going to input, all these commands need to be validated. That is what need to be done, that are not going to be directly sent to the compiler. You're going to validate all your commands before you're going to use in the program. The next one is XSS, that is cross-site scripting. Now this cross-site scripting, this is among the top 10 web security list. Web application security risk, like within the top 10, one is the XSS. Now this occurs when application that is running on a web gathers data from a user in order to steal it. Now what happens in here, whenever you are searching the web, the attacker in here, he is going to encode a malicious link, that is the one link that has got virus in it. This link, a malicious link, this is stored on the server. Now which server? The target server. On the target server, this malicious link will be given. Now when this link is given on the target server, a person that is scrolling on a specific website, he's not going to identify, he's not going to even think that this is a malicious link. When he clicks on that, all the data is collected by this malicious link from your computer, and then it can be used, like your credit card statements, anything can be captured. So that is why you do not need to click on any link that comes as a pop-up or an advertisement whenever you're searching the web. So this is used when you want to steal the information from a person, you go for XSS. The next one is failure to handle errors. Now, by the term itself, you can identify what this particular problem is. The failure to handle errors. Now, whenever you're designing a particular system, when you're designing a particular system or a particular application, now within this particular application, if this particular application, it encounters a problem. Now, whenever you're designing the software, you do not see that what will the system do when this problem occurs. So in here, what will happen when the problem arises, the system does not know how it needs to behave. So does the application is going to attempt to complete the operation that was requested? That is the problem. That is one case. Or it is going to issue a cryptic message or an error message that will be given to the programmers. Sometimes what happens is when your particular application slows down or it just comes to a halt, it is going to ask you whether you want to report this issue. Whenever you report this issue, that is called as your sending the cryptic message to the programmer. The programmer is going to identify what caused this particular problem, and you might get a fix for that particular problem. Or the last cases, it is either going to stop functioning. Now the cryptic message, it gives you two options, whether you want to send a message to the programmer or you want to end the program or else close the program so that the program is going to restart. So if you fail to handle errors within the software, that is also a problem. The next is failure to protect network traffic. Now in here, protecting the network traffic is when the sender, the destination. In here, they're going to make use of a specific network. All your data is going to travel through this particular network. Now, if this network that you're making use to transfer data, if this is not secure, means your entire information can be compromised. Now, when does this type of scenario occur? This type of scenario is going to occur where you're going to have this public networks. Whenever you've got this public networks, you can face problems. for public networks. Now this public networks are in coffee shops, bookstores, hotels, anywhere. When you've got this public network, when you access these public networks, these are not secure. That is why whenever you're connected to a public network, you should not send any secure information through this network. Now this public network, these are basically your wireless networks. Now if you go for any wired network, now whenever the traffic that is traveling through this wired network, this can also be intercepted. Now this interception, it can happen by sniffing the packets. That is what information you're traveling across the network. You've got the sender, you've got the receiver or the destination. This is the network on which you're traveling. So in here, when your packets are going to travel from the sender to the receiver, there is going to be a person or a hacker that is going to sit here, and he is going to see what are the different packets that you're transferring. Now, if your packets that you're transmitting, the data that you're transmitting, if that is not encrypted, that information can be easily captured by this hacker computer. So whenever you are whenever you do not have a secure network, then you should not access any personal information. Or you need, when you have the end-to-end encryption, then only you need to transfer back. That is this particular channel where you got end-to-end encryption, those channels are going to be secure channels. Failure to store and protect data securely. Now by this term also we identify what this particular problem is. Programmers are responsible, that is the people that are designing a particular system or a particular software. Whenever they are designing the software, these people are responsible of how you're going to give access to the people or access to the database, or how you're going to transfer information, how you're going to safeguard that data. That is the job of the programmers, what security mechanisms you're putting in place so that you're going to safeguard the network. Now if suppose the programmer, they are unable to implement sufficient strong protocols to make your data secure, your data is going to become vulnerable. Now if suppose you're giving very strict access controls, if you're having for every task you're having a strict access control, this is going to degrade the performance of the business, because a lot of time is going to be wasted on the different access. Whereas if you do not put any administration, then also it is going to be of high risk. The next is failure to use cryptographical strong number or strong random numbers. Now in here, many modern crypto systems, they use random number generators. Now these random generators, these are used as Monte Carlo method for forecasting. Now what is this Monte Carlo method of forecasting? Now this Monte Carlo method of forecasting, or this Monte Carlo simulation, this is used to understand the impact on a particular risk, the impact of risk. Or this can also be used to make predictions. Now you can make a prediction that if you're invested in a particular asset, what is going to be the value of this particular asset, how well this is going to provide, or what is going to be, whether the price is going to go up or the price of the stock is going to go down. That is going to be predicted. Now these predictions are based upon random numbers. This is based upon random numbers. Now you cannot know actually what is going to be the best approach, or what is going to be the cost of the particular asset. But if you study the historical data, or you hire some expertise on some specific field, or people have got past experiences, This can help you make estimates that are going to be nearly accurate ones. So if you are unable to make use of this Monte Carlo method for your business, then again you are going to be in loss. Now this using this Monte Carlo method of forecasting, it is going to identify the different risks for the particular market, because whenever a particular organization, where you're developing softwares or any other field, the entire organization, it is going to be based upon assets. What is, like, whether the values are going to go up or go down the stock market, they're going to invest and they're going to withdraw their funds based upon these random predictions. So in here, if you are unable to provide this cryptographical methods for this Monte Carlo method, then again it is going to be a loss for the organization. The next is format string problems. Now this format string problems are, what are format strings? Format strings are the embedded characters like percentile x, percentile d, percentile p. These are all called as your format strings. Now, within this, a computer language is equipped of built-in capabilities to reformat data. That is percentile C also. This is used for characters. You've got percentile S, many more are there. So this entire programming languages, they depend upon the format strings. Now, if suppose a particular programmer, he is making use of this format string from untrusted sources. That is, he is just downloading a code online and dumping within the system. So this format strings, the attacker is going to access all of these format strings. He might overwrite the portion of target. That is, if he wants to access some specific part of the program, he is going to make the change within that particular line of code. Now when you're executing this particular file from untrusted sources, when you execute this program, this is going to run, this virus is going to run, and this information will be captured by the attacker. So that is a format string problem. This is going to be the malicious input that is given into your system by making use of untrusted source code via online sources. In the online sources, they are going to embed malicious code within this format strings, and when you run those programs, you're going to have those particular part of the program is going to be compromised. The next is neglecting change control. Now, whenever software is being developed, when you develop the particular software, the developers are going to implement this change control mechanism. Now, within this change control mechanism, it says that now in here, this is multiple developers are going to be there within the software. This developers have developed the software. Now, whenever this 3 or 4 developers have made one particular software, but making changes within the software, these are given to authorized people. Now in here, this change control is given so that multiple developers at a time do not make change within the software. They do not, that is, multiple developers should not change the code. That is why you're adding this change control mechanism. Only authorized persons will be able to make changes within the software, and whenever you're making these changes, all of these changes need to be tested, and then only they need to be released. That is in the form of updates. You should not neglect change control, as if multiple people are making changes within the code, multiple errors are going to occur, and it might affect multiple parts of the program. The next is improper file access. Now within this improper file access, if an attacker changes the expected location of a file by intercepting and modifying a program, the attacker can force a program to use their own files other than the ones that the program is supposed to use. Now in here, whenever you're changing the location of file, that is when you've got an user, this user needs to access a file. This is a password protected file. Now you've also got an attacker. Now this attacker, he does not want that this particular user gets access to the file. So what is this attacker going to do? He is going to add a file. Now this file is the file that attacker has made. Now when the user is going to try to access the particular file, this file 1, he is going to be directed to the attacker's file. Now this attacker's file, you're changing the location. Now within the same memory, you're adding your file in place of this file. You can completely remove this file and put in your file. So this user gets access to this particular file that was placed by the attacker. Now when this file is accessed by the user, this file might contain malware that is going to be executed when the user is going to open this file. Now within this improper file access, there is a potential for a lot of damage. Now and so it is critical that it is important to protect not only the location of file but also the methods that you're using, method and the channel by which these files are going to be accessed. That is, you're not only going to safeguard the particular file, you're also going to safeguard the location of the file. That particular location should also be private, and how you're going to access the file, the commands that you're going to use to access that particular file, that also need to be secure, so that an attacker cannot change the location of the file, or he cannot make changes also within the file. The next one is improper use of SSL. SSL is your secure socket layer. Now, many programmers, they are going to transfer any type of sensitive information, that is your credit card information or any personal information. This is transferred by making use of the secure socket layer. Now the secure socket layer, this is implemented between the client as well as the server. These both people are going to communicate via SSL. Most programmers assume that using SSL guarantees security. Unfortunately, the more often that not mishandled this technology. Now, what does this mean? Now, we make use of secure socket layer. And before secure socket layer, we made use of TLS. Now, what is TLS? The successor of SSL, it is your transport layer security. Now, this SSL and TLS, both of them, these are designed in a way that they are going to do certificate validation. Certificate validation is done so that you can identify the channel that you're using, it is secure. Now, within this, if you fail to make use of HTTP, now whenever you're accessing a bank page, when you're going for personal banking, this HTTP page, this turns into HTTPS, that is the secure layer. Now, if you are unable to make use of HTTP, that is used for certificate validation, then you might fail to secure the connection between the client and the server. Or this can be done, or validate the information, this information, now the information of the digital certificates. This is going to be validated by the certificate authority revocation list. Now within the security certificate authority revocation list, the certificate, those that have expired or that were duplicated, those certificates are not given any certificate. That is, those are placed within CRL. That is, those rights were revoked by the CA, that is certificate authority, the person that is giving. So this is certificate authority revocation. So all the certificates that were revoked or expired, these are stored within CRL. So any certificate that is present in CRL, that is not going to be used for validation. That is, it is not going to turn that site into HTTPS, because that is not to be trusted. The certificates that are present in CRL, they are not trustworthy. Now the CRL, it has got all the list of the digital certificates. These digital certificates are given by the certificate authority. This is the person in charge to issue and revoke the certificates. Now, even if you're making use of HTTP, HTTPS, there is a chance for secure socket layer hijacking. Now, what happens within this SSL hijacking is that the intruder or the attacker, he tries to take advantage of an active session. That is a person that is currently engaged within the server, that is this client and server, they are exchanging information. So this intruder is going to make use of this active session. Now within this active session, what he is going to do is, now whenever you're running a site, you're going to have this HTTP cookies so that this site can run faster, or the pages that you have accessed, those can be accessed at a very high rate. So what this attacker or this intruder do is, he's going to hijack this HTTP cookie, and this is going to be used to identify what are the login credentials, that information is captured from this HTTP cookie. Now what is the countermeasure that can be used to avoid SSL hijacking? Now the countermeasures that can be used to avoid counter hijacking is, you need to have end-to-end encryption between the user and the browser. Now when you have this end-to-end encryption, any unauthorized person will not be given access. Unauthorized person will not be given access to the session. Within the session, no unauthorized person will be given the access. Or else the next step is, you can make use of virtual private networks to encrypt the traffic, that is all the data that you're sending. This can be used for encryption. Or the third one is, as the main target of SSL hijacking is, you're making use of HTTP cookies to get access within this active session. So within this, this web server can generate long or random cookies so that the attacker cannot be able to predict the cookie session. Or one more technique that can be used is automatic log off. Automatic log off. Now within this automatic log off, if suppose you're accessing this online banking, you're accessing the online banking or internet banking page. Now if suppose there is no activity for some specified time, this entire this online banking session, it is automatically going to log off as no activity was detected. Then again, the user needs to identify itself by giving the user ID and password. Then again, you're going to be given access within the system. So these are the three ways in which you can avoid SSL hijacking. The next one is information leakage. Now, employees are the biggest risk of an organization. These people, like, they might intentionally or non-intentionally speak organization secrets to a person. So in here you need to warn the employees so that they do not disclose any information about the organization or what task they are performing. This need to be maintained. The secrecy of the information need to be maintained. The next one is integer overflows and underflows. Now within this, integer overflow can cause the value to wrap and become negative, which is going to violate the program's assumption and may lead to unexpected behavior. Now, what does this mean? Right? If we take an example, if suppose you're making use of an 8-bit integer addition, where you're going to have addition, if you're making use of 127 plus 1, the result is going to be negative 128. This is called as integer overflow. In here, you're giving input that is more than the buffer can hold. At that time, buffer overflow indicates that as whatever value you're adding, it is going to be converted into a negative value. That is called as your integer overflow. The next is the integer underflow. Now within this integer underflow, this is a condition which arises when you're giving some smaller value than the actual memory can store. Now suppose there is the memory location that can hold values up to 0 to 255, but you're giving a value that is negative 2.5, or you're giving some value like this. So this value, this is not within this particular string. So again, this is going to have the integer overflow. Now this type of error, they can also occur if suppose you've within the recent days we have listened of the news of the killer wallpaper, where downloading a particular wallpaper is going to crash your phone. Now what was the issue within that? Now within that, every image that you download, it has got some RGB value, that is the red, greens and the blues. You've got this all values that are rounded off. Now if suppose now in here this problem arises within the Android user interface. Now there's some specific rounded off values that were used within this RGB specification that was given, that was the particular value of the killer image. Now if you downloaded this within the Android UI, it made your phone to crash. Why? Because the Android, it can support the values that were one less than this particular value. So the same way in here, you're going to have integer overflows and underflows. If you're giving values that are more than the particular buffer can hold, it is going to give you different errors within the software. For a few cases, when this error arises, you can recover. For a few, you might not recover. The next one is race condition. Now this race conditions we have studied within operating systems. Now when does this race condition arise? This race condition arises when failure of a program that occurs when unexpected ordering of events in the execution of the program results. Now this is going to happen basically in critical section problems. Now what are the critical section problems? The critical section is your shared memory. Now we have studied a problem within the operating system. You've got this readers writers problem, right? Now within this readers writers problem, for this particular shared location or some specific critical section, that is within the specific critical section, that is the shared memory. Within this problem, multiple readers can access the critical section at a time, but when the writers are accessing, only one writer can access the critical section problem. Now to ensure that only one writer is going to access the critical section, we make use of locks. mutex locks, mutual exclusion principle, where whenever one writer is accessing the critical section, he is going to put a lock that no other person is going to access. Whereas when he is coming out of the critical section, this lock will be changed to 0. That is, any other person can enter. So you need to also focus upon the race conditions whenever you're designing the software. Now, if suppose multiple writers at a time enter the critical section, multiple readers and writers enter the critical section, what happens? It is going to have uncertainties within the data, because multiple people are even reading the data and multiple people are making changes within the data. That again is going to have an error within the software that you're running. The next is SQL injection. Now, SQL injection, again, this is the most common web hacking technique, most common web hacking technique. Now, within this SQL injection, what happens that the attacker places the malicious code in SQL statements. Now, how he is going to make changes within the SQL statements? Now, this is change within the SQL statements are given via web page input. He is going to make changes through web. Now, in here, this making use of SQL injection, it can infect the entire database. It can destroy the entire database because you are changing the entire input of the web page. Now, if we take an example in here where you are trying to retrieve some hidden data, when you want to access this hidden data, you're going to make modification within some certain SQL query. Now, when you make changes within the SQL query, what is going to happen is that when you give input, that if suppose you are given an input as retrieve some specific user ID, where user ID is equal to user ID. Now, if suppose the user gives input as 1, so wherever you've got this value 1 is equals to 1, it is going to retrieve all different files that have got the value 1. So in here, this attack SQL injection, it is normally used so that you can extract hidden data of a particular organization. That is, when you make changes within the code, it is going to give additional results, not only the specific values that you've requested, it is going to give all the values. Now, when all the values are displayed on the screen, it is easy for the attacker to get access to the data. From different tables, you can access the data. From all tables, you can get the data. The next is trusting network address resolution. Now, what you do is whenever you're entering a website, that is, suppose you enter www.google.com. Now, when you enter this particular address, this is going to be changed into specific domain name system. Then it is going to convert it into IP address. Then it is going to make the HTTP request. Then based upon that, you get the response. Now, if you're making changes within the domain name system, that is, you can make the change within the initial name or you can make change within the IP address. Now, if you make change within the original IP address, then the user that has requested a specific page, that is going to be directed to a fake web page. Now, when you're directed to a fake web page, this can be designed in such a way that all of the user input can be captured from this fake web page. All of your credentials can be obtained, all of your personal information. That is the trusting network address resolution problem. Now, this can happen for many banking sites. That is, in place of the original banking site, you've made a duplicate banking site. Now, when you enter the details, the OTP, everything, they are going to put in all of the details within the original web page and they are going to transfer all the funds. This can also be used for phishing attack. The next one is unauthenticated key exchange. Now within this unauthenticated key exchange, you will, now whenever you're encrypting the data, you make use of two types of keys. You either make use of public key or you make use of the private key. Now making this public key, this can be sent over the non-secure channel or it can be shared publicly. Whereas this private key, it is only available with the owner. But what if the person who is going to receive the key, that they have made a copy within the USB device, or if you're making an online delivery, the packet was intercepted, or you're sending over the public network. If suppose this key is available to the hacker, then the entire data is going to be compromised, because in here, to encrypt and decrypt the data, you need two types of key, the public key and the private key. Now when you're sending this public key and private key, whenever, even if you're sending on a public channel, you need to have this public channel should be secured, so that any person cannot intercept or copy the information that you're sending. That is one other problem that is called as the unauthenticated key exchange. The next one is use of magic URLs and hidden forms. Now within this magic URLs and hidden forms, what happens is that many times when you're making use, whenever you're made an HTML web page, if suppose some critical information, it is saved as a plain text, that is, it is not encoded properly, then by making use of magic URLs, the attacker can go through the code of the HTML page and he can access your data by making use of the magic URL. Now to avoid this type of problem, you need to test all the web inputs or forms for any type of malicious input. If you're using any cryptographic approach, you need to identify the strength and weakness of that particular approach. And one more thing that you need to do is you should not embed any confidential data within the HTTP forms or the construction of the template within the URLs or cookies. You should not have any confidential data. Now why you should not have this data? Because if the channel that is used for accessing the specific website, if it is not secure, then all of this confidential data that you are embedding within the HTTP URLs or cookies, that is present in the form of plain text, and the attacker will be easily able to access the data. And you should not trust any data. Do not trust any data that is in a web form, because malicious users can change the data regardless of the security, that is the SSL that you're using or not, because the attacker is not going to try and identify what you've, one second, because the attacker is going to attack the system in many ways. For example, an attacker, he is not going to guess the random numbers or the cryptographic messages. He is going to try and view it, because you have embedded within the code. That is why any personal information, confidential information, it should not be embedded within the HTML forms. The 19th one is use of weak password based systems. Now whenever you're providing password protection to a particular file, or whenever you're giving input, whenever you're given password to any account, any social media account, you need to make use of strong passwords rather than weak passwords. Now if you make use of weak password, it is going to be a failure upon the password strength. That is, you have a password policy that is going to tell you you need to specify numbers, characters, uppercase, lowercase, that need to be there within the software. Now by making use of these many cases, this is going to make your password strong. That is, it is going to be, it can withstand a brute force attack. And the next slide shows what is the protection for each password. Now within this, if suppose your password length is 8, the maximum number of guesses that can be performed are these many. And the time to crack the password is 7 seconds. Now if you go on, if suppose the password length is 16, it might take 46,094.1 years to crack your password. Now this is an estimate for the brute force attack using the standard alphabet set with numbers or special characters, that is all the 26 characters. Whereas this is here, this is a extended data set with case sensitive letters, that is uppercase, lowercase, all the things you're using. So within this, if you have the password length as 8, it is going to take up at least 18 hours to crack the password. Till 16, you can see the time increases, and this is up to so many years. So you need to have a stronger password, you need to have strong passwords, and you need to change your passwords within the certain time. You need not need to write down your passwords. The last one is poor usability. Now within this, employees many times they prefer doing things the easy way. You've got two ways, you've got the official way and you've got the unofficial way. So people many times they go for the unofficial way because it is easy, whereas they do not go for the official way because it is tiring, and it is also, now it is tiring, time consuming, but it is safe. That is integrating security, usability, adding training, awareness, ensuring solid controls. These all things, they are going to contribute to the security of information. Your information, in order to be secure, you need to put in certain protocols, how people are going to use it, that is the official way. You need to add training, what are the different steps that they need to ensure to encrypt the file. Awareness means what happens if they do not go the official way. All of this are going to give the security of information. They are going to allow users to default to easier, more usable solutions with inevitable lead of loss. That is why you need to go for the official way. So these are the different 20 deadly sins within, or you can say the different security problems. So with this, we end the first unit.